All right, we're going to do some problems for three-dimensional coordinate systems. So let's take our first example here. And we've got 3 points. 2, 1, 6, 4, 7, 9, and 8, 5, negative 6. You could draw this out if you want to see what it looks like, but we really don't have to. What we're going to be asked about is this, what kind of triangle is this? Is it equilateral? Is it a right triangle? Is it isosceles? Is it scaling? We're going to figure that out. Or could even all 3 of the points be on the same line? That can happen too. All right, so I'm going to call this point right here, I'll call that A, call this one B, and we'll call this one C. All right, let's start with the distance between A and B. So AB. Okay, so the distance is equal to, just like we had before, the difference of each of the squares, yeah, or the difference of each pair of coordinates squared. So 4 minus 2 squared plus 7 minus 1 squared plus 9 minus 6 squared. All right, so that is going to be equal to square root of, and grab your calculator if you need to, but we've got 2 squared plus 6 squared plus 3 squared. And that is equal to 49 underneath the radical. So that is 7. Okay. Got that one. And let's do B to C. Distance here is equal to so B to C, so we'll start off with C first. So we've got 8 minus 4 squared plus 5 minus 7 squared plus negative 6 minus 9 squared. And so that is going to be equal to square root of, so we've got 4 squared, and then negative 2 squared, and then negative 15 squared. So put that in, and we get okay, so we've got 16 plus 4 is 20, and then 15 squared is 225, so it's going to be square root of 245. And let's see, square root 245, so 5 goes into that, 49, so that looks like 7 square root of 5. Okay, and last one here, we're going to go from A to C. And our distance here is going to be equal to one day I'll remember that the scroll button is not the page up and down button. All right, so we've got 8, 5, negative 6, and 2, 1, 6. Maybe I'll use it here. There we go. Okay. So we've got 8 minus 2 squared plus 5 minus 1 squared plus negative 6 minus 6 squared. So a minus 2 is 6, so 6 squared, plus 5 minus 1 is 4, so 4 squared, and then minus 6 is negative 12. So negative 12 squared. And that is equal to the square root of 36 plus 16, which is 52, plus 144, so that's 196, which is 14. Okay. So there we've got the sides of our triangle, and to make things easy, we can just draw ourselves out a triangle here. Call this A, B, and C. Okay, so A to B is 7, and B to C is 7 rad 5, and then A to C is 14. So it's not equilateral or isosceles. It may be right, and so we're going to check that real fast. And to see if it's a right triangle, the angle that would be the right angle would be this one, and we're going to check that. So, is it right? So we're going to see if 7 squared plus 7 rad 5 quantity squared is equal to 14 squared. Now we should probably see if 7 rad 5 is greater than 14. It is, actually. So let's fix that. Just realize that rad 5 is about 2.2. And 7 times 2.2 is bigger than 14. So that would make this angle down here. Is that the right angle? All right, so 7 squared plus 14 squared, does that equal 7 rad 5 squared? And we got 49 plus 96, 196. So 49 plus 196 is equal to 7 rad 5 squared, we know is 245 from up here. So that's going to be 245. And is 49 plus 196 245? And it certainly looks like it. And I got 5, carry the 1. 1 plus 4 plus 9 is 14, carry the 1. And we got 245. And so yes, it's a right triangle. So this is a right triangle in 3 space. Okay, so next example here is going to take a relation, equation, and turn it into the equation of a sphere. So we are going to have x squared plus y squared plus z squared minus 8x plus 8y plus 2z equals 3. So I know that this is going to be a sphere because all three of my variables are represented as squares, and all of the constants in front of the squared terms are all the same. That's got to happen in order for us to have a sphere. If I did have numbers in front of x squared, y squared, and z squared, you're going to divide them out so that all of their coefficients are 1, no matter what happens with the other one, with the other terms. And then we're going to take and collect everything. So we're going to bring the x's together, and then we're going to complete the square on that. So half of b squared. So half of 8 is 4, squared is 16. So I get plus 16 here. And there's my first one. And then grab the y's, put them together, and complete the square. So y squared plus 8y. Same number again. Half of that is 4, squared is 16. And then for the z's, we have z squared plus 2z. Half of 2 is 1, squared is 1. And then we got to make sure that whatever we added to the left-hand side, we add to the right-hand side. So 3 plus 16 plus 16 plus 1. So we're going to factor each of these perfect squares. So when we complete the square, we make a perfect square trinomial, and then those get factored. So this becomes x minus 4 squared plus y plus 4 squared plus z plus 1 squared, and then that's equal to 36. So what do we have? We have a sphere of radius 6 and a center. Remember, take the opposites of all of those numbers for the center. Center is 4, negative 4, negative 1. Okay, one more problem from this, and we will call it